So today we are looking at this, the laser trigger. We're using this, which is a laser emitter, and a receiver here, which is a photoresistor, to create an invisible barrier. And when that barrier is broken or crossed, we can get results. We can get actions out. And we can see the red emitter here shows that the laser is emitting, and down here on the photoresistor it is receiving a signal. There is a bunch of stuff we can do with this. One example would be an alarm, one of the most common uses for the trigger. So if I open this up, we have the Arduino set up here. So every time that it is triggered, it's outputting its raw sensor value. I'm going to give it a bit of volume, turn on this. We will see that if we look at the serial, we'll see that we have data coming in, and then we're going through our normal serial process, and every time I cross it, I can make it trigger a sound. That's not all we can do with it. We can also make it, so the idea is that we can make a system. If I load this up using Touchdesigner instead of MaxMSP, I have something that if we look at the window, if I open up Windows 1, and fill the location, so I can make it alter video every time that the threshold is crossed. Here all we're doing is I've got a bunch of video or image layers separated out with transparency, and every time that the barrier is crossed, it is causing the resolution of the center one to change. So nothing overly complex, but it's a live reactive system based on what is happening with the trigger. So we have all our components here. I'm just going to get rid of all of these because we don't need them for now. So I'm going to pull the photoresistor out of the way. We'll come back to that in a bit. I'm going to take all of these out, and I am going to take basically any pin that's not vital. I'm going to remove here quickly. So what I have set up at the moment is I've got my Arduino board connected. I've got a ground and a 5-volt power going to one end of it along the horizontal strips, and then I also have a button set up with what I think is a 10 kilo ohm resistor here, and we are going to write a program that triggers that when this button is held the laser will fire. When it's not held, it will do nothing. I'm just going to slightly adjust. So this is the laser at the bottom of the sensor here, taped to the desk. The reason that we're doing it this way is lasers are very dangerous things. This is a sort of the lowest class you can get. So looking into this and won't directly damage your eyesight, but prolonged exposure to your retina can cause damage. So we want to avoid that at all costs. So I have it taped to my desk in a position aiming away from me. And then over to the left-hand side of my desk here, I have a piece of cardboard blocking it from going any further than that, so it can't go and hit something else within my house. This is just a standard button setup. I'm not going to go through this as the basic Arduinos cover this, but it's powered, and then the ground for it goes through a resistor, and then we have it going to the digital read 12 pin here. So let's set that up. So we'll make a constant int button pin, and we're going to make that equal to, it is 12 on my Arduino board. And then in here I am going to set up the button. So in setup we want to edit the button, and we're going to do pin mode button pin input. So all that's doing is it's when Arduino initializes, it's saying the button or the input on pin 12 is we're going to receive data on it rather than send data. And then we have inside the loop we are going to do button state. We're going to make a variable. We're going to do int button state is equal to 0 on. We're also going to make another one outside of setup called int button state, and this one isn't going to be marked as a constant because it will change. All this is doing is that if, say, for some reason the Arduino crashed or we recompiled the code, it means that the button would be read as a default of off, and that's quite important because you don't want to accidentally trigger the laser in this case. Next thing we're going to do is we are going to do button state is equal to digital read button pin. And in the loop state, we are going to go to the Arduino board and get the value of this button. And then we want to do if button state is equal to, I'm going to double equal to because it's in an if statement, high, then do something. And inside this we're going to do when button is pressed, and then we'll do else when button is not pressed. And I am going to use the LED on the Arduino board to test this. I'm going to do const int LED is equal to, that's always on pin 13 on Arduino. We are going to do pin mode LED is an output, and then we are going to do when button is pressed digital write LED high. So when the button is pressed, turn the LED on the Arduino board on. Digital write LED low. When the LED isn't pressed, let's check that code. I'm just going to save it under, where am I going to put it? That's a good question. Inside my program for people, Arduino Sensors. I'm going to make a new folder here for the tutorial. And inside here, I'm going to do main Deadman button. It's going to check that we've not made any horrendous mistakes. And for what felt like the longest compile ever, we're going to send that to the Arduino board. So now that it's done uploading, so in theory, every time we push the button, the LED which is here on the camera illuminates, and when it's not pressed, it doesn't do anything. And you'll notice that it does the occasional flicker. That's because this button is super loose in the breadboard. But there we go, we can see it working. So now we can comfortably hook up our laser and know that we can control when it's on or off, just for our safety while we're testing with it. So the next thing we're going to do is we are going to introduce our laser. Now to hook this up, so if we have a look at the laser module, you can see we have S, 3 pins, and then a minus, and it also has a resistor built into it. S is signal, and the minus is ground, and that resistor is connected across the signal and power pin. So we know that it goes signal, power, and then ground. So that's how we're going to wire it up down here. And thankfully these pre-built modules already include the resistors and stuff with it, so all we need to do is wire it up correctly. So I've got my 3 cables set here, where I have my black is the ground, my white is the power, and my grey is the signal. So if you can, use the correct colours, as in black for ground, red for power, and then something else for signal, normally blue. But as long as you keep different colours and know what you're doing, I trust that you'll be safe. So I know I'm going to attach my power to orange so it's nice and bright. And then I am going to attach my signal to grey, keep it consistent. And finally I am going to, if I can find it, attach my earth to white. So I'm going to put all 3 of these cables into the vertical of the breadboard. So we have now plugged in, we have power, earth, and signal. So we're going to, let's connect the power up to the power channel. And then we connect the earth up to the earth, or the ground, excuse me, not the earth. And then finally, we want to take the signal to a digital read pin in the Arduino board. So I'm going to go to digital 8 up there. And now let's go back to the code and have a look. So we know that our Deadman's working, but we need to add different options for the laser. So we're going to add another constant because we plugged something into the board. I'm going to make a laser pin, and I put it onto 8. Inside setup, we're going to initialize it. We're going to do pin mode laser pin is an output. And then finally, we are going to go down here, and the exact same way that we did the digital write with the LED, we're going to digital write our laser pin to high, and we're also going to digital write our laser pin to low. I'm going to do Command T to auto format this. Check the code. Always compile, as in check for errors before uploading where you are potentially using something dangerous, so like a servo, a motor, or a laser in this case, because there's when it's a more powerful object, there isn't really any room for error. So now that's uploaded, and we can see down here that when the button is on, the laser fires. When it's off, it doesn't. On, off, on, off, on, off, on, off. So that's us tested the laser, but at the moment it doesn't really give us anything. We need some way to get feedback in to Arduino. Now for my examples, I'm going to use the same machine, but you could quite easily set up another Arduino on a receiving computer. Because of the grade of this laser, it comfortably cover about 10 meters before you degrade the beam so much that you can't get a discernible value. So you could have one PC firing the laser. Not even that, you could have an Arduino programmed to fire the laser. It just needs to be provided power, and you could have your photoresistor about 10 meters away receiving it. And that is creating your invisible line that you cross. So what we're going to do now is we're going to wire up the photoresistor. And before I start that, I'm just going to unplug the power and the earth, or the ground. So I'm going to do black and white from my laser, so that even if something happens to the button, as I said, it is very sensitive, that it doesn't fire. So in the same as with the laser, the photoresistor, if I grab one of these, is set up in a signal 3-pin ground on the outside. So signal, power, and ground. Again, we supply it with 5-volt power, and it will work. The only main difference is that the signal for this one, we are going to plug into an analog read because we want a streaming value. So here I have green is my signal, yellow is my power, and then orange is going to be my ground. So I have signal, power, ground. So this is my ground. And again, this is a prime example of why having good, correct colors is important. So this is my ground. I'm going to plug that in here. Yellow is my power, so I'm going to plug that in here. And then this one here, green to black to blue, is my signal. So I am going to plug that into the analog read 0. I'm going to use an extra extender here. So I'm just going to plug that into analog 0. And now if we go back to the code, once again, we're going to make a constant variable. And this is the photo pin. But this one is on A0. We are going to be using the serial port to display the info here. So let's get rid of that rubbish. I'm going to initialize the serial. So I'm going to do serial.begin 9600. Because the sensor is on an analog pin, we don't need to initialize it. But down here, we want to set a new variable for it. So we want to get the value that's on it. So we're going to do int photo level is equal to analog read photo pin. And just like that, now in the photo level integer, we have the value that the photo resistor is reading. And the way the photoresistor works is that it has a higher, the more light that's shining on it, the lower the resistance, so the lower the number that goes through it. So we get the value, we have whether the laser is on or off. So at the very end, we want to add serial.print. I'm going to do print on a new line every time it does a value, photo level, and then I'm going to add a slight delay so it gives us a better accuracy. It means that this photo sensor will have caught up with the most recent light. Check that. I'm going to upload it, and while that's uploading, I'm going to plug back in my sensor. So that is my ground, and that is my power. So I don't know if the camera shows it that well. Let me create a better dynamic. So when it's pushed, you can see the laser light shining all the way over here. So we know it is still compiling properly. And if I open the serial monitor, we should see it pulling values. So at the moment, there's a default light ambiance of about 200 to 300. Turn on a laser, it goes all the way down to 50. On, off, on, off, on, off. So there is a concernable difference between the value when there is a laser and the value when there is not a laser. And we can use that handily, because it's being printed to the serial port, we can use that most places. So I'm going to minimize Arduino, and I am going to open MaxMSP. And in here, first thing I'm going to do is I'm going to open serial, and we want to double check, so I'm going to do the print command in here, and that's going to tell me that on port E is COM5, which is the serial port our Arduino is connected to. So now we can do serial E9600. I'm going to put in a toggle and a Metro 100. So I'm going to pull the serial port every 100 milliseconds, which is slower than we are uploading to it in Arduino, so we'll always get the most up-to-date value. Turn it on, put in a message just to make sure we're getting a value. We are not. Error opening serial port, so I probably have the serial port open somewhere else. I am going to cut that. There we go. So I had Arduino was open, that was technically still pulling the serial port. So now I have it, so I closed Arduino, cut and paste the serial to reinitialize it inside MaxMSP, and now I can see I'm getting values through. The 10 means that it's seeing the carriage return at the end of the serial, but we can fix that using the method that we always do, which is we are going to add a select 13, which is space. 13, which is carriage return, 10, which is space. And then we're going to group anything that comes out of it. And make it an arbitrarily big group. And what this means is anytime that it receives 13, it's starting a new line. Anytime it sees 10, it knows it's the end of the line. So what we should get out are the commands, or the ASCII, that relate to what's coming in of the serial port. Each of these refers to a single number, so this is about 55 or so, 54. So now we know we're getting the values. We need to turn those values into something, so I'm going to do ITOA, and converts two integers from Unicode, and then from symbol, which converts from what is being read as plain text into an actual number. So if I plug this into an integer box, we'll get no argument over here, and we're getting the number of the value. If I cross it, you can see it jumps instantaneously. Now we could contain that. Let's encapsulate that and call that the serial read. So that's just a bit neater. That's something that you can save and use anywhere. It's just a good way of getting raw values off the serial port as long as they're printed onto one line. You will need to turn it on and off again. Now let's do something with that value. As this is an analog reading versus, say, a digital that's on or off, it's best if we put it through some sort of expression or logic to make sure so that we get either an on or an off value. So the easiest way to start is I'm going to load in an if statement. I'm going to say look at the first value, and then if it is greater than 100, then bang. And that's a good value because you can see that our ambient is around 60 or 60 to 70, and then anytime that we interfere with it, it changes from sort of 600 down to about 300 depending on how close to the center I break the laser beam. So this is just going to say that basically anytime it's broken, then bang. We could have a running calculation that takes the average of the ambient over a long time and then does an increment over that. That would be what I would develop if I was making this for a big installation. For example, I would take a consistent reading of this number, which is the laser on, and then anytime the value is sort of 20% bigger than that number, then we consider it as broken. And that just means that you have an ongoing, a dynamic system for ongoing changes. Say you're in a warehouse or an art exhibit, things like that. The light is going to change throughout the day, so you want to know you can rely on your installation to last. So we plug in that, and now if I do a button, anytime the beam is broken, we'll see that we're getting a bang out. So we can do something exciting. In the demonstration at the very start, I had it going into a cycle. So let's do that again. So I'm going to create a cycle with a starting frequency of about 440. We're going to put a line into that so that we get a nice smooth generation. And then we're going to create a message that says $1 20. And all that's going to do for us is it's going to that is going to be the target time for the line to generate. It just means it smooths out the information going into the cycle over a very small period of time rather than bombarding it with changes. I'm also going to make use of the value coming out of this. So I want to make a linear line using so this little tilde means that it's an audio signal or a signal, but I want to make it out of general integers. So I'm going to use the line, and it gets passed messages of where you want it to go to over how long. So this says go to the value of 4000, the default value is 0, over 150 milliseconds. And then I also want it to reset. So it's gonna be like a sine wave. It's gonna be a parabola. It's gonna go from 0 to 4000, and then from 4000 back to 0 again, all within 300 of a second. So we bang this when the ramp ends and put it back into the start. So now if we visualize it, we'll see it goes from 4000 up to 4000 and back down again on a really quick loop. That's the number we're going to pass into the cycle to give us any time that the alarm is or the trigger is broken. It ramps up, and then while it's as this continually bangs, 4000 will keep triggering, meaning that it won't go down again until the line is below the value. So while we're crossing the laser beam, it will be 4000. Anytime it's not, it will be 0. I'm just going to pass that straight into there. I'm going to do a gain control and then an easy DAC. Hook that up there, that up there. Take my cycle in, give it some volume, listen to it. So it's a really low bassy because we're so low down. Plug in the bang. Oh, that's not where that goes into that. So now anytime we cross the beam, you can see that the value increases up to 600. Line is at 4000. The second I remove it, it ramps down again. So here we have a really simple alarm that when the laser is being crossed, we hear a noise. When it's not, we don't. Simple. We can do things slightly more exciting. You could, for example, I'm going to save this and call it Max Alarm. I'm going to use an alternative to Max called Touchdesigner, which is much more about the visuals in it, where Max is, you could say, an audio programming tool. Touchdesigner is incredible for dealing with really high quality, high resolution video to do a number of things. It's used from show controls through to large stage events. There are some other videos on the channel about it if you want to go and check it out. But first thing I'm going to do is I'm going to make a serial. I'm going to hook it up to the correct port, which I know the Arduino is posting to COM5. I'm going to change the amount of data to 1, and then I'm going to turn this into a chop, which means that I will have the value coming in from this message as something to use in Touchdesigner. So now I have a numerical value of the sensor reading coming in. We have loads of things that we can do with this as well. I could visualize it nicely for you. So this trail shows us a running total over the past 4 seconds of what is happening. And you can see anytime I cross it, we get that beautiful arc up and down. And the reason it arcs like this is because some of the laser light is still touching the sensor until I completely occlude it. So it's not a straight on and off reading that we get. It's a partial based on how much laser light is actually getting past my finger. For example, here I'm about half covering the sensor. No cover, full cover, half cover. So really you have a lot of scope to play with. We could do it something, again, Touchdesigner does have the ability to play audio files. We could hook this up to, so if we do a maths, plug that in, and then we do a from range, we know that it's going from about 75 up to 700 on a 0 to 1 basis. Plug that in there, excuse me. We'll leave that up there as a visualization for us. So you can see we're getting a value here. I'm going to use that to directly control the volume. So depending on how much I cover the laser, depending on how loud this gets. That's probably going to be very noisy on the microphone, so we'll delete that. But let's look at what we can do with it visually. So let's bring in a movie file. So the same way as before, what I'm going to do is I'm going to add this into an expression that gets me whether it is on or off. So I'm going to do same way as before, it's an if statement, but this is a slightly more complex programming language. So I'm going to do if. I'm going to do 1 if me.val is greater than 100 else 0. So a simple expression. I now have what we in here would call a trigger or a bang, similar to MaxMSP. What I'm going to do is if I add this to a window, so what I'm going to do is I am going to 300 by 200, make that a native resolution. I'm going to use this 1 or 0 to control something between here and here. So I'm going to make a new constant and call this randoms, and then I am going to add a chop execute, and then off to on. So anytime that the laser is crossed, we're going to do something. And we are going to do op randoms dot par value is equal to something, and then we're also going to do that the second value is equal to something. And I'm going to do random dot randint 0 to 1000 random is not defined. Going to add a round 1 and round 2. So now every time it's crossed, 2 random numbers will be created between 0 and 1000. And here we're going to do a res, high quality resize. We're going to do a custom resolution that is based on our 2 values. And we're going to keep the aspect ratio the same as the input. So now, anytime that we cross this beam, it's going to distort this image based on a bunch of random values. And let's do it a bit more intense. So let's do it between 0 and 10,000. That's slightly too opposite. Let's do it between 0 and 100. So now no matter what we do, it looks like we're getting that weird pixelated effect. So that's just some really quick examples of ways that you can use what we've made in a practical development environment such as Touchdesigner or MaxMSP. So really the world is your oyster, but that is using a laser and a photoresistor to make an invisible trip switch or a massive distance covering trigger. As I'm saying, with the one I've got, I've tested up to about 10 meters. A stronger laser, you can go further, but please just be aware if you are going to build something like this that you be careful using laser technologies.